And when we get to the prerequisites, I'll talk a bit more about them again anyway. So, hi. I'm Ashish. How many of you guys have done any kind of web scraping before? Okay. So a bunch of familiarity. I hope that you guys will still find this interesting. I think you will. So I started really using Python, wow, this is 2012, I guess about 11 years ago, and it was mostly to extract structured information from unstructured text. And then a year or two later, I discovered that this applies to websites too, and I got really into web scraping with Python. So over the years, I've collected some tips and found some good resources, and I thought I would put together this tutorial and share them all with you. So thank you all for coming. There's some cool stuff in this presentation. There is the potential to totally abuse all this for fantastic evil. And in fact, I'll demo that toward the end. Try not to do that. So the talk is going to be a combination of me explaining the concepts behind some code and why you would pick one tool over another. And also we'll spend a lot of time looking at code in an editor. So there'll be plenty of room to ask questions about the code. One question people do have about web scraping in general is they ask me, surely you should be using some sort of standardized API for things rather than pulling data out of web pages. It seems kind of brittle, but actually, I found that it's not very brittle. I found that when I write a scraper, it seems to keep working for between 1 and 10 years. Like, APIs aren't usually supported that long. I think that, in general, people who put websites together, if you're going to put a website together, if you're going to do nothing, then my scraper is going to keep working. And I think the most common thing to happen for websites is that their maintainers just stop caring. So active redesigns can break some scraping, it's true. But on the other hand, really active redesigns end up with the web designers and the web techs communicating a lot about the structure of the HTML, and then the web designers just adjust it in CSS. So you'll see from the tools we use that if you use the same tools that CSS-based web designers use, your scraping will keep working even through a redesign. So here's this slide about where to get the sample code. The sample code is in a bit of flux. Sorry about that. So if you go to this repo and you clone the repository, there's a whole bunch of directories, and then there's a directory labeled new. All the stuff I'm going to be talking about is based on that new directory, but to those watching after the fact, this will get cleaned up so that it'll just be at the top level later. Is that clear to everyone? Is there anyone? So if anyone wants me to wait a little longer to install these things, I just installed them myself here. If you use Debian or Ubuntu, you can install any of these with Python hyphen, whatever the name of the module is, all lowercase. On other platforms, I guess you can use pip or whatever you like to use. So with these, you should be able to actually run the demo code. The other thing is that you really, really ought to, if you have Firefox, take a minute to search for Firebug on the web and get that. Or if you have Chrome, does Chrome come with the DOM inspector bundled? Anyone know? Yes? OK. So if you have Chrome, I'm going to be demoing things using Firefox's Firebug, but you'll have the same interface on your own computer in Chrome. And I'll show you that in a second. So in general, if I'm going too fast, you should slow me down. If I'm boring you all to tears, you should let me know, and I'll try to talk faster. You should feel free to interrupt and ask questions in the middle. I want this to be pretty interactive. I want you guys to get a lot out of this. I do think that we're going to end up with a substantial amount of time at the end for questions also. So from my perspective, what that means is if I'm unclear about something during the tutorial, you should all just stop me, or whoever feels I'm unclear. You should say, what is going on? Or raise your hand. What yeah, beautiful soup. Yeah. Yeah, sure thing. So yeah, there's also going to be plenty of time at the end for questions. I think that'll be pretty fruitful. Do whatever you need to get the most out of this, basically. So just to summarize different perspectives on scraping. Sometimes one category of scraping is that you have this enormous web page, maybe of a bunch of address book data that was exported from some web app. Well, it wasn't exported, it was just rendered by the app. And you need to pull out lots of data from that. That's this one page case. Another case is when you have an entire website that has pretty similar templates across the pages. And you need to download probably the whole thing, or you'd like to download the whole thing and apply the same extraction to each page. Another form is where the website is actually a web app that has some code running in the background that you can interact with over forms, and most of the scraping I've done has been, well, half of the scraping I've done has been one-off. And any of these three categories of things, I've used the tools that we'll talk about today to write data extractors. I've tried to crawl entire sites. Sometimes you want to keep doing these periodically. Like say, when I went to college, I noticed that the student directory listing didn't have a very useful interface for searching it. Like, you could search people by first name, last name, and their dorm numbers and their phone numbers, but somehow the front-end search just didn't work. So what I did was I left all the search criteria blank and I pressed search. And then I got the entire database. And that fits into category 1 here. Then I had to learn a lot more about Beautiful Soup and tables. But what I discovered was that it was convenient to just keep doing this every semester. So I'd have a copy of the student directory as it gets updated. So we'll talk later about how to write code that's especially good for reuse and modification later on. But if a lot of what you end up doing is just short one-off hacks, then that part won't be as crucial to you. But I guess what I'm saying is I found my one-off hacks to often turn into long-term projects. So, and in general, I have this perspective that for any website that has some code in the background that accepts the form data as the input, it's providing you an API. And some sites also provide other APIs, like REST APIs, JSON APIs. But what I find is that these APIs often have less functionality than the website itself. So why bother with the official API? And if you think about the uptime guarantees, right, the people who run the site care more about making sure that real users see their content and that users can log in and edit their data. So they're providing you the API, the official API, probably without a service level agreement, whatever, just use the website. So I'm going to talk about this particular website, which I think is pretty cool. And I'll have to retype it. So Cepstral, that's tiny, right? So Cepstral is a company that makes some text-to-speech software. And so you can check out their cool demos on the web, and then if you're convinced that they make the best text-to-speech software, you can pay them lots of money to give you a copy of their software. But what's interesting to me is that some of their demos you can't even pay them for. So here, the company is talking about how great it is that they can tune a voice that's generated from text to particular applications. One of our clients needed a voice that was excellent at reading weather forecasts. So here, you can interact with that voice over the web. But you'll notice that these voices are proof of concept only, and you can't download them. You can't even buy them if you were to try to. So this is the only API available to that code running somewhere. And you can bet they're not going to publish a real API. Let's see how this goes. So we're in Santa Clara. Let's be David. So you click submit on the form, and it takes you to this HTML page, but most excitingly, it gives you this audio link. I hope my audio is working on my computer.
At 4 p.m., the temperature is 61 degrees Fahrenheit. The wind is from the north at 7 miles per hour. The barometric pressure is 30.2 inches and steady.
So that's something that you can only get over the web. There's no API for it unless you just believe that the website is the API. So let's go with that. A tool that I've been using for a long time to interact with forms on the web is called Mechanize. I'm just going to show you some code now that uses Mechanize to interact with this form. And over the course of this tutorial, we'll talk more about how that code works and what it's doing behind the scenes. So let me make this a little bit bigger. Control plus. Sadly, no. Oh, here we are. Pardon me. Okay, that should do. Is that readable from the back? Okay, great. So this is a really simple bit of Python code. We start by importing Mechanize and setting up a constant. It's just this one little function. So we create a browser object in Python. We open the URL we named above. We select the form. We fill it out, with Santa Clara. We set the state, and we submit. And I just have a little main function here that'll print the output of this. So let's run that. What did you say? Wow. Eek. No, apparently it'll only be 44. Okay. This is why you should do your laptop setup before the beginning of this tutorial. Yeah, so I'm going to run this code. And assuming we didn't take down their site. Yeah, okay, great. So here's some HTML. I was really hoping for the audio file. That would be a much more useful API than a soup of tags. Newsreader Kevin. Anyway, so we got some HTML. I wanted a WAV file. If you look at this HTML here, somewhere in this, yeah, so I'm just scrolling up. You can see the message about the current weather when it said at 4 p.m. the temperature is 61 degrees Fahrenheit. And here is the link to the WAV file. I mean, maybe in the back you can just trust me that what that says is something.wave. In fact, it says ahref equals something.wave. Okay. Well, there it was. So we can parse HTML, or in this case, we can just notice that that link was between quotation marks. So if we just use string splitting to split this on the quotation mark character, we'll end up with a list of junk. Some of the things in the list will be the link to our WAV file. So maybe I'll just try that here in the interpreter to make sure that's clear. Let's save the output to a file. We're going to open up that file. Read it in. And somewhere in here is the .wave link. We can just use string splitting to get an enormous list of stuff that's inside double quotation mark characters. One of those is going to be the WAV file that we saw between the href marks. Is that clear to everyone? Okay. Yeah, so I wrote a trivial bit of code to show that. So this trivial bit of code will find the this WAV file in that split string. And let's put it all together. So you saw the just post by mechanize function which submitted the form. This is a this code is called altogether, and it'll submit the form, find that wave link, turn a relative URL into an absolute URL. So the link that we get is relative. It starts from slash. We have to add on the domain name that it started from. And then, if we're lucky, we can play it from Python. So let's give this a shot. All together. Submitting the form, I guess.
At 4 p.m., the temperature is 61 degrees Fahrenheit. The wind is from the north at 7 miles per hour. The
Yikes.
barometric pressure is 30.2 inches and steady.
So ignoring the terrifying errors from mplayer, we've got our API. This thing didn't expect to be a web service, but it is. So that's, for me, the core of the fun of web scraping. So, there's another example I want to step you through at the beginning. This is a photo of some Indian food that my coworkers and I used to go out and get when I worked around the corner here at Creative Commons. There's a restaurant called Mehfil, and we called it Curry in a Hurry. They have this menu on the web. So in the first example, we used this website as an API. Here, I'm going to just show pulling out a bit of data. Well, the question I want to answer is, every single day, I only want to know about the menu they have if there's eggplant on the menu, because I love eggplant. So let's see. Let's load up that menu. As a human, I can just Control F and find eggplants here. Plural, don't know why. So I'd rather save myself the chore of that. And so I wrote a little bit of code that I'll step you all through that will answer that question. So this should look familiar. We're using mechanize to grab the page, and I'm just finding out if eggplant is in the string that the page gives back to us. So this seems perfect. This is the kind of thing that you could put into a cron job. If there is eggplant, it'll print yes. And if it's in a cron job, it'll get emailed to you. So that's all you need for notification. Are there any ways this could be improved? Or any problems with it that you guys can see at the moment? Right, if eggplant is capitalized, then I'm screwed, he points out. So we can search the lowercase version of the string, I guess. Any other? Yeah, so you might like to know what the dish is, you point out. And this is the dumbest possible tool for finding out if eggplant is on the menu. Yeah, so there's no structure here at all. And I think that we'll talk more in the future about it, but I think that it's possible that different HTTP encodings might even mess this up. Oh yeah, and I guess if for some reason their HTML editing tool stores the string eggplant as like that, then I won't find it. So this is pretty dumb. But it's actually doable for a lot of cases. So one question I was asking in the beginning was, is this so brittle as to not be worthwhile? And actually, these examples I've been using when teaching scraping for 3 or 4 years now. So apparently they won't break. We'll talk more about a non-stupid way to get the HTML data out so you're not splitting HTML and strings. And we'll also talk more about what Mechanize does behind the scenes. It seems like a kind of black box you instantiate a browser object in. The other thing is that this is kind of slow. So you notice how in the beginning, when I wrote the code to post the data to Cepstral, it waited a while. Every time I ran the code, to get the audio recording out from the weather program, it took a while. We'll talk a bit later about what's a good way to cache those. And yeah, we should probably talk about HTML at some point. So there's 2 obvious ways that are great to read HTML, and they both are in the web browser. One is to view the source code of a page, and the other is to use inspect element. So let's go back to the Curry site and view source and see what they have there. So this is a real specimen of a web page. Some of you may already know that web pages are supposed to start with the HTML tag. This web page simply omits it. This is actually fairly common. So, as soon as you get to byte number 4, this is invalid HTML. The web browser doesn't seem to care, though. And the HTML goes on and on. I want to also emphasize the inspect element feature. If you haven't used that in Chrome or Firefox, you should definitely do it. So this is giving you an interactive tree view for the web page. One interesting thing is it actually injected its own HTML element. Because web pages, well, the document object model specified for HTML says that all pages have an HTML element, so it guessed where to put it, which is at the beginning. This is also kind of pretty printed and indented. It's a lot nicer looking. Just like, if you look at the indenting here, it sure is a lot nicer than this tag soup. I really love this web page because, so it's clear from a few little bits that it's maintained using Microsoft Office. MSO Far East font family is some non-standard style attribute value. Yeah, and then there's these amazing empty paragraphs that are special kinds of Office paragraphs. Actually, so for those familiar with XML namespaces, this is pretty clearly an XML namespace use. But the HTML tag is gone, so we'll never know what the namespace was. It's really, this is the kind of thing that used to be really popular on the web. Total trash HTML. Yeah, so I want to take a second to contrast the HTML with its modern variant, supposedly XHTML. So they're both trees of tags, they're both well standardized. HTML is from the beginning of the web, and XHTML is from the year 2000, the future. So it took over, right? Any thoughts? Are we all XHTML all over the web? Oh. Okay, so that's a drag. There's been some research over the past few years as to what a normal web page looks like. So I'm just going to do a bit of a pop quiz here and ask you guys a few questions. How big do you think the average web page is in kilobytes? How much? Half a meg. 1 meg. So in this survey, they found it's about 16.5 kilobytes, which seems pretty reasonable. That Curry page is probably a little bit longer, but most pages are probably shorter. Yeah, so someone said that HTML has not lost totally to XHTML. Actually, XHTML is doing okay. About a third of the web pages on the web declare at least that they are XHTML. So that seems like good news. But web browsers have been around a long time, and website maintainers have been hacking all sorts of trash HTML like you saw on the Curry page for ages. Web browsers have these two major modes for rendering a site, Quarks mode and standards mode. In Quarks mode, the browser tries its best to seem like Netscape 4, basically, and it applies certain fix-ups to the parse tree and the actual meaning of the elements. And in standards mode, it doesn't do that. So, I mean, many of you are probably familiar with Quarks in standards mode. How many percent of the pages on the web do you think are rendered using the browser's automatic, probably not standards compliant detection? Yeah, 90, 95, 85. So the web is in slightly better shape than you guys thought, but it's still kind of a mess. But what about validation, right? Maybe these HTML web pages, even though they're not XML valid, they might be HTML valid. So what percent of web pages do you guys think validate according to the standards? 2%. Any other takers? Come on. You guys are so pessimistic, but you're not so far off. It's 4%. Nice. So these are from a few years ago. And I think that these numbers have been getting better over time. And I think a lot of that has to do with the rise of automated publishing tools. And like, this web page, right? It's unconscionable. There's no HTML tag. Things like this are on their way out because of the rise of automated tools. But still only 4% validate, so. Okay, so, you guys think pages that on the web as a whole are pretty low quality. What about pages that have a little badge that say standards compliant, click here to validate? Yeah, about half and half. If you assert it, it's a coin toss. So one of my favorite questions in this research study was which tags are most commonly used. So I'll tell you one tag that's nearly not used at all, which is the Ruby tag. It's for displaying particularly Japanese characters in the right visual alignment. It has nothing to do with the programming language. But title and body, right? Two essential tags to any web page. Which one do you think is more common? Both pretty essential, right? Yeah. So I've heard some bodies from the left side here, but actually title is more common. And if you think about it, it makes sense, because title clearly does something. You'll notice if you don't put it in. Body, I mean, like, this thing doesn't even have an HTML tag. Body, who cares? So much of the web is a mess. On the other hand, a lot of the stuff that you interact with automatically is probably generated by robots, automated tools anyway. So since the web is such a mess, many people like to use these regular expression tools to slice and dice the web, not as an HTML document, but as a string. There's a famous quote by Jamie Zawinski, who was instrumental in the development of Netscape and now runs a bar near here, which if you guys have some time, you should probably go to. It's called DNA Lounge, and there's a 24-hour pizza place next to it called DNA Pizza. But anyway, yeah. People in the Perl community, the 90s especially, were like, text? Data? Yes, regular expressions. It's going to be great. And now they have this extra limited tool for understanding this complex document. I want to take a second to explain what's wrong with using regular expressions for HTML. So there's this graphical tool called Kodos, which I'll launch. So let's say you want to find... That's a bit small. Can you guys in the back read the text on the top? Okay. Well, I don't know if I can do anything about that. I hope to, though. So let's say that you want to find a link. You've got this, you've got some web page to whatever that links to whatever.wave. That just says ahref equals whatever.wave. Imagine you're searching that. You might think, okay, I'll write a regular expression that matches everything inside the quotation marks. And that works out great. And in this GUI, you can see that it matches whatever.wave, so you would extract it properly. But tomorrow, the web designer might make this irrelevant change to replace the double quotes with single quotes, which is totally valid in HTML. And now your regular expression, because it assumes you're using double quotes in the HTML, matches nothing. Fine, you say. You will let you use single quotes or double quotes. And now you win again, and you've matched whatever.wave. You can go back and forth on these, but if the following day the website changes to something like this, wait, why did that work? Oh, I see. Well. Point is, if you use double quotes on the outside to delimit the string in HTML, you can then use an apostrophe. You sort of can. You're not permitted to, but people will. Use an apostrophe inside the link text. And now your regular expression is too dumb to figure out that this apostrophe in the middle is not the end of the link. This is actually a fundamental categorical flaw with regular expressions. They can't track which version of an alternation was used on either side. So in the end, regular expressions can't do everything you need to pull data out of HTML. But there's a bunch of things it really is good enough for. So we didn't even need regular expressions to do the simple stuff we were doing before. And a lot of automated templates that are in websites will have things like will let you paginate. And it's pretty useful to use a regular expression. So if you're trying to scrape Yelp, for example, you might use the number of reviews you see on the page to give you a sense of how far along you are in harvesting all of their data, which is a great idea. So, and I say that because I haven't read the terms of service. So it's good for trivial things. Regular expressions are good for text. In particular, this word reviews might show up as just review. Yikes. It might just show up as review because it might become singular if there's only one. So totally a good idea to use regular expressions here. If you are going to use regular expressions, I really do recommend you use some sort of GUI for tracking how they're being matched. So I really like Kodos. Years ago, I found redemo.py in the Python source tree, and apparently it's still part of Python if you download the source, but it's not been maintained in years, so you should use some more modern tool. There's also some regular expression GUI tools on the web that let you visualize how your expression gets broken up by the pattern matching engine. But the point of this isn't to talk about regular expressions, it's just to save you in case you want to use them. So, John Postel, who wrote some of the early internet standards, created this notion of being conservative in what you generate, and be liberal in what you accept. So, you're going to have to parse whatever trash the web gives you, but if you're writing web pages, try to write good stuff. So let's talk about parsed HTML. The Cepstral site that I showed you before is pretty basic. So if we take a look at the source tree of this in inspect element, this is cepstral.com/cgi-bin/demos/weather. It's a whole bunch of lovely tables, right? Like a table, inside that table is a table, next to it is a table. This is the way the web was in like 1999, and it was pretty cool because you could align stuff. There's a bunch of websites that are a lot newer, and one of the reasons I bring this up is that the strategies you'll want to use to pull data out of different sites will vary based on how old or new school they are. So Cepstral you saw is a bunch of nested tables. The meetup.com site, which you might want to pull data out of, probably uses no tables at all. Divs everywhere. Spans, divs, classes. So these elements have some semantic hints for the web designers. This is d_photo group, and we'll be using those sorts of things later. If you're lucky, the websites you want to pull data out of look like this, where things have names. And why am I on Ron Paul's meetup? Anyway. We're going to talk more about different HTML parsing tools in a bit, but my favorite is lxml.html. And so I'm just going to show you guys a code sample for using this on Cepstral so that instead of doing stupid string hackery, we actually parse the HTML. And that's in altogether LXML. So this get wave link looks pretty similar. We start by getting the URL we start by submitting the form as before, and then we pass it to lxml.html. And this gives us an HTML object, and we get the root element here, which is the HTML tag. And LXML is smart, it'll introduce an HTML tag even if there wasn't any in the original document. So from then on, maybe I can format this a bit better. We use CSS selectors. So how many of you have written CSS in your coding careers? Wow, great. It's a new world. So yeah, so you use this trivial CSS selector. You get all the A elements, and then you get these Python objects that represent those A elements. So I just first pulled out all of the hrefs, and if the anchor didn't have an href, I get the empty string. I filter in the list comprehension to get only the ones that have wave in their link, and then I pull them out. I pull out the first one. There's only actually one. And then it's just the same as before. We tack on the beginning of the domain, etc. This one doesn't actually play it through mPlayer, but parsing HTML can be pretty simple. So a couple of things that people like to do when they get HTML in terms of just text processing is they want to remove all the tags. So if you have like a block of text with some bold and italics in the middle, you just want to throw away the formatting. You might want to take entities like ampersand hash 95 that I mentioned early on that might trip us up on the eggplant search. You might want to convert those into plain old Python Unicode strings. And you might also want to take the document tree you've parsed and generate the source code. So LXML has some pretty good tools for doing all that inside it. Every LXML element contains a text content method that'll get you just the flattened text. Entities like ampersand, hash, whatever, will get converted into Unicode strings automatically at parse time, and you have to call this separate function toString in the LXML HTML module to get your source tree back, but it can do that too. So LXML to HTML seems pretty convenient. How many of you have used it, actually, while I have you all here? I'm curious, what have the rest of you used for parsing HTML if you have? Beautiful Soup, HTML5lib. Beautiful Soup. OK, yeah. So this is great. You should all use it, and I'll tell you a bit more about really why later. I want to go into a bit of a digression about HTTP. So how many of you are familiar with HTTP headers? Right, great. So just to emphasize how they work, when you get a web page like ashish.org, oh, I should try that again. Your browser sends some, oh man. Well, your browser sends some headers. Sure. A whole bunch of them. And the server sends back some text about the data, and also the actual page. Status codes, it seems like you all are pretty familiar with HTTP. The 2XX series is success. 4XX means error. Some common ones on the web are 404 not found and 402 payment required. OK, that's not very common. But it's actually part of the standard in the beginning. So back in 91, 92, when the web was beginning, it was clear that micropayments were right around the corner. And so 400 is bad request, 401 is not authorized. And if you're not authorized to view a page, then you go through this back and forth dance with the web server to say, oh, here's my credentials, and the server says, great, now you can get it. Or 403, you're forbidden. With 402 payment required, presumably you'll do some similar standardized back and forth to pay for resources on the web. 410 gone is like 404, except it means this page is never coming back. You'll never find it again. And there are some extensions to the HTTP standard, like the hypertext copy protocol on April Fool's Day a few years ago, which specifies some more error codes. So the basic HTTP methods are get for downloading pages, post for modifying resources by submitting forms, and put for uploading files. And of course, the hypertext copy protocol provides some more. As it happens, if you try to brew against a resource that is not a coffee pot, you might get the error, I'm a teapot. So it seems like you're pretty familiar with HTTP. Just to summarize how cookies work, cookies are used to keep track of clients on the web. This sounds so like I'm giving you all a lecture in 1999. But in case you don't know, individual web transactions are stateless. So you get a web page, and the server sends you back the page, and at least in the beginning, the server will close the connection. So if you were supposed to log in, the connection's closed, how can you log in? So the server sends you back a message saying, set this cookie on your own web browser. And then every time you request a web page again, you say, hey, I have this cookie with some values that you sent me. Usually these are just session IDs. Sometimes they're complicated data. I guess there's a whole world of exploiting and hacking cookies, which we're not going to go into. But the important thing is that if you try to use urllib2, if you try to use the most basic of Python web page downloading tools, you'll have to worry about this. And if you use either requests or mechanize, then these are handled for you automatically. And we'll talk a bit, well, I'll show you some more sample code that uses requests in a bit. So actually, I'll do it right now. Why not? So in terms of posting to this weather form, I want to show you some sample code in using three different Python web HTTP APIs. The first is urllib2, which I think is what, no, we used mechanize before. So it starts pretty similarly. Here I use Beautiful Soup to parse the page. We just make a dictionary. The one interesting thing about the dictionary is that it contains values that we didn't see when we were filling out the form on the web. Like this thing, synthesize the weather. I didn't see that on the page. I know to put these into the post data because I saw them when they were sent by Firebug. So I'll just do a form submission over here so that you all get used to seeing the net tab. The net tab here, sorry if you're in the back, is the last item on Firebug's DOM inspector, well, past the DOM inspector, and it's available in Chrome's debugger tools too. So if we try to post the weather to, post a request for the weather for Santa Clara, Firefox will tell us that it submitted these pieces of data. Zip empty, submit. This key in this dictionary is called submit. It says synthesize the weather. So it's these data that I just copied right into this Python dictionary here. We encode it into the HTTP encoding format, which Firefox also does for us here. And then we submit it. And then we get back this file object that represents the response. So that's one way to do it. We saw how to do it with mechanize, and that's a lot simpler. You don't fill out the hidden form data. I also want to show you how to do it with requests, which is this newfangled hip urllib2 replacement. So it looks pretty similar to urllib2, only we don't have to encode the data manually. We can just submit this dictionary. One really cool thing about requests is that if you had some amazing Unicode values for these dictionaries, you would probably run into problems with urllib.url encode. If you had some like binary junk that wasn't safely encoded as a Unicode string, urllib would do its best but probably corrupt your data. Request is actually smart, so you should use it when you're doing post. Long story short. And it's on PyPy. It's under a really permissive license. Kenneth, if you watch this, you're welcome. So, yeah. So those are the code samples. One fun fact about the web is that usually, if you're going to do a get on a page, if you did a post on the same page, you get the same data back. So I'll just quickly demo that on ashish.org. I haven't rigged the demo. It's just a site that I know that the administrator won't mind. OK, so there's ashish.org with a get. If I do a post, I get the same thing. It's not clearly useful, but you might end up, this might come in handy sometime. So this is the basics for pulling data out of web pages. I want to talk a bit about how web servers are expected to communicate with bots and like web crawling agents and how that'll affect you. So there's this great file, robots.txt. How many people here have not seen robots.txt before? OK, well, sure. So robots.txt was a standard from the mid-90s where search engines found that people's automated web crawlers, well, no, sorry, website maintainers found that people's automated web crawlers were hammering their sites, and they were indexing pages they didn't want indexed. And this is actually before it was clearly legal to even link to web pages that nobody gave you a link to. So people would add this file, robots.txt, to the top of their website, and it gives information to different automated user agents. So this one says, to any user agent, you may not crawl the site at all, except you can crawl this one site, crawlme.html. So just to get a sense of how people use this, let's look at the robots.txt for Google. Who crawls the crawlers? So if you're a bot and you want to follow the rules, you can't do very much. You can download some small part of their catalogs. If it has any highlighting string in it, you can't get it. This is actually a really interesting list of things on the site. I don't know what JSKY is. Anyone have any idea? Yeah, so there's all this great stuff that you may not get. Now you can, technically speaking. And actually, it's pretty convenient to get stuff even when you're not supposed to. So let's talk about that. There is a standard for how these robots.txt files are supposed to be written, and you can read more at robotstext.org. However, there's one thing I should emphasize with robots.txt, which is if you are writing a crawler and you get robots.txt on a domain, that's a really solid fingerprinting technique that site can use to determine that you are probably a bot. Humans don't just surf to robots.txt on sites that nobody links them to. But automated agents are supposed to download this first and use it as rules. So if you get this, sites might come after you and be like, hey, you know what you weren't supposed to do. But if you don't get it, then they might not know you're a bot, and also, how could you know? Yeah, so don't ever get it. Like, I've ruined this IP that I'm on. Now if I try to harvest data from Google, they'll be like, of course they had bots crawling all over that network. So let's fill out a form to search the web on Yahoo. One question that keeps me up at night is the question of if I'm still the top Ashish on the web. So let's test on Yahoo first. So it would be pretty simple. We would just instantiate a browser object, surf to Yahoo, fill out a form. I already looked at the form before. I know that the search query form is P. This search searches for PyCon, but we'll get to the real important searches later. So hopefully this will just submit. Let's run this sucker. Let's see some results for PyCon. Actually, we're not going to see any results because we don't do anything with the file object at the end. But we should at least not see an error. But what we see is an error. And what error do we see except for a robots.txt error? Yeah, HTTP error 403, request disallowed by robots.txt. And actually, the mechanized toolkit is stopping us. So it's not that Yahoo has actually served us this 403. It's an internal error in mechanized that's this Python module is so nice. If it detects you're not supposed to be doing something, it'll simulate an error across the network for you. So you can disable that. And you just call this function here. Set handle robots false. This is like the third thing I had to learn about. So if we run a slightly modified version of this code with set handle robots false, the bottom there, we're waiting. It'll eventually succeed and print nothing, which is to say it didn't give an error. We don't actually do anything at the end of the code. So that's good. Now we know how to avoid being caught as a robot. I've been using Mechanize so far, but you can actually just fill out the form directly. There's no hidden form data, so there's no need to use to load the first page that contains the form. Let me just show you a couple of demos of that. Yikes. So this is the base. So let me explain how I got this URL. If you go to search.yahoo.com and you search for bananas and you hit search, there's all this stuff in the string, yeah. And then you finally get $P equals bananas in the URL. So I just figured in my Python code, I'll just get the URL P equals whatever I want. So I do call urllib.quote so that things like Unicode characters and apostrophes get escaped so that they fit in here properly encoded. I pass that to requests. I parse the result. I look at all the items whose CSS class is URL. And I figured out that because I inspected this element and found that the class... Oh. Well, there's more up still? Or? Oh, yeah, thanks, exactly. Yeah, so this span has class URL. So in the code, we just slice out all the objects of class URL, and we print the first one. So here we can easily find out if I am the top of Sheesh. So let's check that. Oh. Or let's fix our demos. Yeah, okay. Ashish.org is still the top hit for Ashish, so I'm safe for now. It's worthwhile to run this every day. You shouldn't just check it when you give presentations. So why don't we check the same thing on Google, too? We'll do the same thing. This time I use Beautiful Soup for no reason. And I also use urllib, too, to get the page just to keep things exciting. So again, we look for this tag site, which contains the URL. And I know that because I've done this search in the web browser. I've inspected element before. Oh. Man, I thought I did this. Oh. Stack, 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 stack. 4 to 3 forbidden. So, I didn't do anything too fancy here. I just loaded a web page. Why would they not let me do it? While I was testing my demos, I thought I might try rewriting this using requests. So I have that up here for you. It's really the same. The only difference is that we use requests here, and irrelevantly, I use LXML to parse. But it's this get that was crashing. So why don't we try running this? Presumably it should crash too, although I don't know why they're forbidding it, right? Maybe I had a different version. Anyway, that's my excuse. I should, if any of you wants to write that, then, oh, well, okay, so it crashed here, but most importantly, it didn't crash here. So it got the page with requests, but it wouldn't get it with urllib 2. What gives? Anyone have any ideas why? Yeah, the user agent is the right question. I don't know what requests uses, but basically I presume Google doesn't either. And they're used to people scraping their site with urllib 2 all the time, send a particular default user agent. So let's show you how to swap that out. So here we're going to pretend to be Microsoft IE 5.0. Actually, let's be IE 8. I like IE 8 better. On Windows 98, sure. All the different web page downloading tools we've talked about let you set your user agent. And just so it's clear to everyone, the user agent is a header that's supposed to indicate to the web server what kind of web browser you have. So if you have an iPhone, you should say that, and then the web server can know that. I think that it's not permitted in the HTTP specification to send different data to the client based on their user agent, but I guess Google's doing it anyway. So we'll run that code, and it should get all the way to the end without crashing, and it prints the entire Google page. Look at all that delicious HTML. Santa Clara, wow, great. Eeks. So, yeah, and there's some more sample code that shows you how to do this using urllib 2. The requests documentation online shows you really clearly how to do it using requests. But I want to show you guys something particularly exciting in terms of IE 5 versus IE 8. So in Firefox here, let's switch my user agent to IE6 and go to Google and search for Ashish. So it looks like this. If we switched up to IE8, the top border becomes black. So the website is pretty clearly sending me different stuff based on my user agent. Luckily, I'm still at the top. So actually, the user agent you use to request the HTML in Python might mean that you get different HTML back than you got back in the web browser. So if you're searching the DOM in Firebug and you're like, where is my site tag? Actually, this version of the HTML doesn't have any site tags at all because it's for Internet Explorer. And if I switch back to using Firefox, iPhone, who knows, default. Yeah, let me inspect one of these guys. Yeah, if I'm using Firefox, I get this nice pretty site tag there. So that's something that you really have to pay attention to. Yeah, I think that's what I want to emphasize there. So in terms of HTML parsing, there's one question I think is very interesting. What does a parser do with invalid HTML? So if you're trying to pick a Python web parsing tool, web page parsing tool, you probably want something that will handle invalid HTML just fine. You might want something that handles XHTML properly. Actually, if you have really solidly pure XHTML with namespaces and all, you probably want to use an XML parser, not an HTML parser. Having said that, the first bit of XHTML we saw was the corrupted word-based curry menu, where they're using namespaces, but they've lost the namespace declaration. So probably you want to treat you may want to treat everything like tag soup unless you have a reason not to. Yeah, and in terms of treating proper XHTML, they're all fine. There's a whole bunch of samples in this parsing directory inside new. I'll go through those in a second. The other thing I want to emphasize is the difference between a parser and a tree builder. So there's at least two things you might want to do with the web page once you download it. You might want to extract the structure from it and make a parsed tag tree in memory. And the other question you might want to, and once you have that parsed tree, there's all sorts of different APIs for searching that tree. So, it'll become clear when we look at the code. So let me talk about two bundled Python batteries included HTML and XML parsers that should be great because they're part of the standard core. How could they let anyone down? So let's look in these. Parsing. Yeah, so in this parsing directory, we have a few files, invalid and valid HTML. These two are valid. These two are invalid. Let's look at this code to parse one of these with HTML parser. So HTML parser is actually an unusual kind of parser. It's event-based, not full tree-based. So it reads tag fragments little by little and modifies its state. This is a very memory-efficient way to parse HTML, but it's also kind of a pain. So this kind of could use a little smaller. But this HTML parser subclass, the goal is to take an HTML page and extract just the contents of the title element. So there's these two flag values we have. One is a Boolean if we're in the title, and the other is the actual value of the title. And as the HTML parser gets more data fed into it, it calls this, if the data type that it gets is a start tag, like P or title, it calls the handle start tag method. Our handle start tag checks if the tag in question is title, and if so, we set self.inTitle to true. And then whenever we see character data, if we're looking at the title, if we know that we are in that title tag, then we append that to our long growing title string, and when the title tag ends, we set inTitle to false. So if we run this thing, we could instantiate an HTML, our parser object, feed it an HTML string line by line, close the parser, and pull out the value inside the instance of the class. So let me just show you some of this crazy HTML I have. This one's pretty normal. Wow, that's too dark to be useful. So here, there's just a title of Yo-Ho-Ho. And this is sample valid HTML. It's so valid, it has a doc type, and it has an HTML tag. Life is great. If we try to parse it with parse the HTML parser on sample.html, it prints a bunch of logging messages and then successfully finds the title. If we pass it some invalid HTML, let's look at this invalid HTML, I guess in a browser. So this thing is a pretty simple, sucky web page. It has an HTML tag, but it starts a paragraph in the middle. I don't even know what the correct behavior is. In fact, this is just invalid. It shouldn't work at all. In Firefox, it presumes that the title is this entire string, including angle bracket p angle bracket. So it decides that this is just a typo. It's supposed to be a character entity, and it keeps reading, waiting for the end of the title. You can see that here. Up here, can't go too close. Where that p tag is sitting inside the title of this window. When we parse it in Python with HTML parser, it just gets the text, not the tag p. I'm not sure what the right lesson here is, except that this web page is terrible. But also that HTML parser in Python did something different than what the web browser did. And just for fun, I wrote a little parser. I wrote a little function using minidom. Minidom is a pure XML parser, so it's super easy. You can just get elements by tag name of title, get the first one, and get the whole text. And if you pass this thing XHTML that's valid, it'll be thrilled, and it'll look something like this. And in fact, that is the title of that document. If you pass it anything else, like my invalid HTML, it's like, no, don't be ridiculous. That's not XML. So these are the two tools you get in the standard library. Actually, you don't want to use either of them. You want to use one of these three, and we'll evaluate these right now. Well, let me give you a bit of history first. Beautiful Soup showed up around 2004 and revolutionized the world of Python web scraping. It actually kind of did. It was pretty cool. How many of you used Beautiful Soup back in 2004? Yeah. You're not signed up for this. Okay. Well, it was a good time. HTML5lib is actually a standardization of the rules for how web browsers should handle invalid HTML, which got standardized in version 5 of HTML. And the history of HTML5 is kind of interesting. Long story short, the World Wide Web Consortium was like, let's all march toward perfect, awesome, valid XML, XHTML, throw away all these bad, broken documents, and live the dream of efficient, straightforward parsers. And, about a third of the documents are XHTML now, and some tiny fraction of them are valid. And other people formed a different working group to create a different standard that was just like, here's what web browsers are doing. Let's at least write it up. So that's what HTML5 is, and HTML5lib is a Python implementation of that standard. And, well, you'll see in a second, but it's kind of slow. There's all sorts of crazy fix-up rules that browsers try to do to make sense of the web. LXML.html, LXML is a Python binding to, I think, libxml2. And it has an HTML module, so it sounds like it's going to be bad news. Why would you put an HTML parser inside an XML parser? It'll probably crash all the time on invalid junk. But it's actually pretty good, and we'll see that. What I wanted to say before about document trees, about searching trees versus just parsing them, will be illuminated right now. So, let me see. Yeah. In this, wow. In this parsing directory, no. Oh yeah. I swore it was here. Okay. Yeah, beautiful soup search. So make tree. But okay. Well, never mind half of that demo. So, eek. Yes. So there's this line of code which you don't actually have the code to execute, but long story short, it takes a web page and parses it. The thing about search is how do you find elements in there? So Beautiful Soup has an extremely flexible API. All sorts of things mean the same thing, and sometimes that's great. So the Beautiful Soup object itself is a callable. You can just pass it the name of a tag you want to search for, and it'll give you a list of all of the, in this case, A elements in the document. It has a long form that's this. And if you want just the first one, you can just use attribute lookup to get that. So this tree.findAll A's at 0 is the same as tree.a. That's convenient shorthand. Beautiful Soup also supports grabbing just the text inside the tag, and you can do this pretty cool search where you pass it functions to run as part of the search process. So this is designed to find just the links that contain the word menu in their href. So if you're trying to pull data out of the curry site, it's a pretty convenient API. And what Beautiful Soup has always had going for it is this crazy, partially complex, but kind of just flexible API for finding elements. One of the fun things is that HTML5lib can actually also give you Beautiful Soup objects. So let me just scroll to the bottom here. The Beautiful Soup module is good for these traversals. It's also been pretty good at parsing. HTML5lib lets you generate Beautiful Soup objects if you instantiate it with this magic. And this should really say soup. After you get it and make a Beautiful Soup set of objects, you can then, on this object, use all the same Beautiful Soup API that Chris and I at least know and love from the early 21st century. So HTML5lib actually lets you generate all sorts of crazy different kinds of tree formats. So you can actually generate xml.dom.minidom trees out of invalid broken HTML. And then you can use XPath from the standard library in XML land if you want. And also it has its own built-in tree format that no one seems to want to use. And actually the most recent version of Beautiful Soup, which is in beta now, Beautiful Soup 4, doesn't really do its own parsing. It relies on these other parsers. Its job is to create Beautiful Soup objects and give you an API to search through them, the same good old complex, powerful API from before. Amusingly, HTML5lib can let you make Beautiful Soup objects. Beautiful Soup 4 can call HTML5lib to let you make Beautiful Soup objects. It's not clear which way you should start, but I think you end up at the same place at the end. And lxml.html gives you this kind of neat trick. How many of you have written XPath expressions? Wow, okay. Why? Oh, okay, good. Scraping is one reason to write XPath expressions. What other reasons to write XPath have you had? Oh, XSL, yeah, XML style sheets. So XPath is this terse it's the language for slicing XML documents up. And wow. That's what I get for moving my stuff around. Okay. Well, anyway, if you parse a document using LXML, you can use XPath selectors if you really want to. I think the most exciting thing is to use CSS selectors. Like, they're super expressive, they're great. They're actually compiled by LXML into XPath expressions, which are then compiled into machine code and executed across the LXML C data structures of your parsed document. So it turns out to be pretty fast. And it's also the most convenient thing. It's also the thing I'm most used to using. And I just want to just run you a quick demo again of the crazy complex Beautiful Soup API. So if you want to, let's say you want to look at some nested tables. This is like what Beautiful Soup was for. Because back in the day, that's all we had. So if you want to find out how Apple stock is doing, one funny fact about this web page is that once it finishes loading, it'll dynamically keep updating. So don't get too scared by that. But there's a table here. There's a div and 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 a div containing a table, tbody, and th. And the data is right here. So you might decide that, well, so here's some ways you can grab access to that data. You can grab the table, grab the first tr, grab the first td, and pull out the text. Or you can find that table by ID, find the first tr, find the first td, and grab the text. Or you can find that table, find the first tr, the td, and the text. Super concisely. And I have these assertions in here just so that when I run this, I make sure that the data that I find in each of these is the same as the data I found initially. It's just the shorthand for the API. Honestly, though, I don't bother. I just use CSS selectors. Oh, what? I totally removed that fix me. Yeah, so I want to show you guys the Kari website once more. One of the big problems we established from the beginning is that I can't tell which item is going to have eggplant in it. And I want to solve that. So here's this lovely website. No HTML tag, but that's fine, because it's got what I need. It's got bold text, some bold text. These look like sections. Let's see what the HTML structure here is like. It should be pretty easy to write some beautiful soup expressions to pull all this out, I hope. So it's kind of a mess and kind of inconsistent. This time, the section heading is inside a style 2 strong style 21. But here it's just inside a style 21 strong. With data like this, where there's no actual elements separating what you want, Beautiful Soup is a really good match, because you can just like navigate very easily along the boundaries between the tags with its API. Yeah, and as I mouse over, it's telling me how to use XPath to find that element, which is not something you should be able to rely on for a messy document like this. So this is the kind of old school thing where old school tools make sense. So I guess we have a break in about 17 minutes. I want to talk a little bit about which parsers are good to pick, and then you guys can have a stretch. So the things you should look for in an HTML parser: how fast is it? Is it easy to use? Does it seem like it still works? And do people still work on it? So Beautiful Soup had this interesting history where Beautiful Soup, revolutionized the world, and then its author stopped working on it for 2 or 3 years. For the first 2 or 3, he felt bad about it, and for the last one, he was like, whatever, I'm done. And then, confusingly, Beautiful Soup has come back from the dead by the original author, and there's now Beautiful Soup 4. So I guess that's maintained now. Not every time I've given this talk has it been maintained. So HTML parser, XML mini DOM, you don't want those. You got to pick between some of these. And Ian Bicking, years ago, admittedly, did a really good review of the performance and memory usage characteristics of these parsers. And that's worth going over right now. And if you see Ian at the conference, you should tell him hi, and that his graphs are great. So, how fast? Yikes. So fast it blows off the screen. Yeah, so turns out LXML.html is very fast, and it's made of C. Beautiful Soup is slow, but HTML5 lib is even slower. And then I kind of don't know why he has Genshi in the mix, because it's not a scraping tool, but fine. Yeah, the fact that LXML.html is 5 times faster than the standard libraries tool is kind of amusing, but it's also more than 10 times faster than the next reasonable competitor. Okay, so LXML.html is fast to parse. It's also fast to take its tag tree and turn it back into HTML. Again, 5 to 10 times faster than the competition. It also has pretty low memory footprint, although not as low as HTML parser. HTML parser is stream-based, so that makes sense. You only ever look at the tags you need. With LXML.html, you have to parse the whole document and then find the bits you want. But it does pretty well. Right. Well, so those characters aren't quite what I wanted. I wanted less than signs. So imagine, stand a little bit to the side, and those are less than signs. A question that I haven't answered is, just because LXML.html is fast, how good is it at handling broken HTML? And in fact, it's great. It's about as good as HTML5 lib. I've never had a problem, and I actually have had problems even with Beautiful Soup, misparsing data. Obviously, it's very fast. So Ian Bicking's blog post has a very clear conclusion. Yeah. Yeah, and you can use Beautiful Soup as a backend for LXML, and I think you can also use HTML5 lib as a backend for LXML, and you can certainly do the reverse. I just use LXML.html by itself. I really am curious if anyone, like ever, has had a reason to care that much about which parser, since these are all great. Little LXML.html and HTML5 lib, at least. But, you know, it's 30 times faster than HTML5 lib, so you should just use it. Oh, unless you can't install compiled Python C extensions. So, if you're in some environment where compiling stuff is hard, then you can't use LXML, and you don't have a package manager. I have a package manager, because I run Debian and Ubuntu, so my life is great, but some of you, I see some glowing fruit logos that suggest you don't. So, well, I can't tell about the other machines. So that's most of what I have for you before the break. We've seen how to load pages from the network. We've seen how to parse them. We've seen a few things about status codes, why the user agent header matters, and how to submit forms, and how to keep a session. Maybe now's a good time for a break, and then after that we'll talk about countermeasures for getting around when people want you to not scrape their sites. Right. Yeah, so the question is if I'll go more into the behind the scenes of how the parsers work. Yeah, I don't plan to here, but there'll probably be some time after, like, in the longer Q&A at the end, and it'll probably be... I wish that I could give you a quick guided tour of one of those libraries, because I'd already done that. I would have to skim the code first to get a sense of it, but we can talk more about that afterward, totally. So maybe I'll begin again. My favorite parts of doing scraping are when you end up creating new APIs that didn't exist before, or you take websites that have published APIs that have less features than the real website, and you automate those. And the other is the question of what do you do in the face of countermeasures to scraping. So one of the subtle questions is, if you set your user agent to claim you are Firefox, can the other side of the conversation still tell that you're not Firefox? So here are some ways that you might fail to appear like Firefox. You might fail to store cookies. Well, maybe the Firefox user has cookies disabled, but probably not. You're probably a bot. There's some subtleties in the headers that Firefox sends. So I want to take a moment to look at some of those in more detail. So Firefox sends a whole lot of request headers. It sends these accept headers that say what kinds of documents it's willing to accept and with what kind of priority, and what languages and character sets it wants to accept and with what kinds of preferences. So also accept language. No Firefox browsers in the world, I think, send no, well, that's totally double negative. All Firefox browsers in the world always send an accept language header. They always say, I prefer English, or I prefer simplified Chinese, or who knows what. But our Python code is probably sending none of that. It's probably not talking at all about language, and why would it care? It's a bot. So anyone who wants to fingerprint you to determine if you are a bot should just look for those headers and say, oh yeah, sure, you're Firefox. Let me give you some subtly incorrect information so that you then misinform your human operator. And then, I really like using IE5 as a user agent in scraping, just because it's so absurd. But there's other things too. So most Firefox users have JavaScript enabled. You can do things like, there are some, I guess the thing that concerns me is that there's all these obvious countermeasures that would detect bots super easily, and people don't do them, and I don't know why. So maybe it means they actually are doing them behind the scenes, and they're just logging what proportion of Firefox is not Firefox, or they're subtly, evilly modifying your data so that you get incorrect stuff. The other thing, in terms of JavaScript, you could, so there's some ways that you can be fingerprinted by just not having JavaScript enabled, but there's other ways in which you can just make the site require JavaScript, and suddenly it's way harder to parse, to interact with. But even just in terms of fingerprinting, this ashish.org page, so this page, if we look at the HTML, I said HTML, okay. If we look at the HTML, there's some inline style here, and then there's an image somewhere. In fact, yeah. So the inline style requires, well, strongly urges the user agent to download this image. So if you're blind, you're probably not going to download this image. But otherwise, if you're actually a real user of Firefox, this would be a great way to track if it's Firefox or Firefox. And same with CSS headers. Like all of the scraping tools I've talked about don't download the CSS that's linked to in a link href at the top of it, in the head of a document. But it's a day giveaway. Come on, guys. And then I'm really waiting for the day where people write fantastically invalid HTML, then push the boundaries so that only real web browsers can parse their web pages. Maybe HTML5lib, but maybe not. Maybe you can push the boundaries even farther. There's a whole world waiting to be exposed. And the other basic ways that you can be detected as a bot, when you go to a web page, by default, you send the web server information about where you came from in the refer header, which many of you might know is famously misspelled. Refer is supposed to be spelled with 2 R's, but this is the way in the English language, it's spelled with 2 R's right here. But in the spec, it's spelled with 1, and that was that. So anyway, if you have cookies disabled, you're probably a bot, unless you're a super privacy conscious human, in which case, why do they want you using their site anyway? And you might have hidden form fields. So hidden form fields are a particularly good way to catch bots, and they're really common in the world of wiki spam and blog spam. You add a little hidden form field to a comment form that says, the visible parts are name, email address, comment, and there's a hidden part that just rotates over time. So then, if you looked in Firebug and captured the form submission today, you can't replay all of that tomorrow and just change the name, etc., because that token has changed. You're clearly using old data. And this is actually how Django cross-site request forgery works. They add a hidden form field that is based on your session. is based on a cookie value. Yeah. So for hidden form fields, if you're using mechanize, you'll get through that just fine. But if you're manually specifying the data dictionary you post or you get, then you won't. Yeah. Yeah, and requests will handle cookies for you just fine too. So how many of you have run into, while scraping, IP address limits where you can only download so much on one address? Yeah, so those are kind of a drag. Behavior profiling, there's this whole world of exciting anti-bot tools that don't seem to be being used. Humans don't do breadth first reversal of a site. They don't click on every nav link even if it goes to the same URL. They don't click on links that are hidden, but bots might. So that's a good way to catch you. And then we'll talk more about JavaScript in a bit. Yeah. So if they're doing behavior profiling, you're doomed. Your bot is not going to look like a human. You're not going to get all the CSS at the right time. Yeah. Let's talk about IP addresses. So there's the tools that I like to use to get around. At the end of the day, you can't get around an IP address block. They're going to be able to find out your IP address if you're connecting to their server. But what you can do is easily write Python code that leverages other computers. You can use their IP addresses to do your scraping. So I'm going to talk about the lightest weight way I like to do that, which uses SSH plus this program tsocks. How many of you have set up SSH tunnels before? Wow, nice. How many of you have set up SSH tunnels with -D? Yeah, okay. So let me make sure I have this program installed. Oh yeah, and this is, well, maybe I'll write a little ASCII art diagram. Do I have a whiteboard? No, yes, no, okay. So there's you. So if you want to scrape some site, you want to hide behind some machine so that you use its IP address to get to them, wherever them is. The way that we'll do that is we'll ask SSH to create this to permit dynamic forwarding. That'll mean that on you can request any page. Instead of requesting the page dynamically, instead of requesting the page directly using a regular IP connection to them, you will connect back to your own machine on a special port that redirects traffic through some machine through this tunnel. And you'll use a tool. You can do that special wrapped TCP connection using the SOCKS protocol. I like to use a C program called tsocks, which will just wrap Python, but there's alternatives that are pure Python that you can use. So I'll just demo it now, and maybe that'll make it a little clearer. So first of all, I'm just going to demo things in the command prompt without Python at all, just to clarify how this works. If you try to get this website, checkip.dyndns.org, wow. If you try to get this website, it downloads it, and eventually it spits out my current IP address. So if I were to get this thing blocked from Google, then everyone presumably inside the PyCon Wi-Fi would be sad. So that just made directly is a connection to these folks there. I'm going to log into a server of mine. With dynamic forwarding. Yes. So now I have a login shell, but most importantly, there's a new service listening on my laptop on port 1080. And that service is a relay service that uses this protocol called SOCKS. So any traffic that I want to not go directly between me and the internet, I can send it through this relay, and then it'll hop to some machine first, and it will do the actual internet connecting. Is that process murky for anyone yet? Or still, I mean. I'm presuming that everyone thinks it's totally clear, or yeah. So right now it will be my server. Yeah, I guess crucially some machine has to be some machine you control. So in this case it's my server. It could be a machine you spin up on Rackspace Cloud or EC2 or yeah, or any shell account. The great thing about this tool set is that anywhere you can log into usually permits this. And by usually I mean the default configuration for SSH permits this and no one ever disables it. So even like, now I'm really going to ruin everyone anyway. But even like random cheap web hosts you can usually use as a relay for this. So if you have like a $5 a month web hosting account, that'll work. But you shouldn't, you shouldn't be mean. I'm just telling you the technicalities here. So, to make this work, you need to make a little tsocks configuration file with just 2 lines. Server and server port, I think. Let me just make sure I will have them right. Okay, I guess I'll just wing it. So this is the most simple tsocks configuration file you can write. I think it's a correct one. So this wget that you saw, sorry about all the bouncing around. Yikes. Okay, so apparently I'm not configuring it properly. It's called server port. Yeah. Okay, so check it out. I have this complex command line, which I'll explain in a second, but the current IP address changed to 199.199 to 210.158. Maybe I'll try to clean this up. Yeah, so the current IP address is that, and if I disable tsocks, it's that. It's really straightforward to write a program that you just have a bunch of these tsocks configuration files. You have a bunch of shell accounts, and you rotate which one you're using at any time. And actually, because in Python, because you can do all this in pure Python, you could actually have your crawler switch every whatever n, 10, 5 requests which IP address it's coming from. So there, in the sample code, there's this thing called socks underscore monkey, which monkey patches the socket module to do this. And then you don't need to use tsocks at all. You still need to use a SSH-D. And this is the way I like to do it. At least this way, I'm using IP addresses that I actually control. You can just buy lists of proxy servers and plug them in. That just strikes me as shady. And all it took was writing this little config file and installing tsocks and wrapping your Python through it. So maybe I'll just do one more version of this where I wrap Python in tsocks just to show that it works from there. So I've wrapped Python. Yeah, and that's the IP address of my server in Minnesota. All just because I wrapped Python in the program tsocks and set this environment variable here. Yeah, so Let's talk about JavaScript-y web apps. As far as I can tell, these are the major two options if you want to. If somebody gives you a web app that you're supposed to scrape, or rather, you decide you want to scrape someone else's web app, and it's rich in JavaScript, it's very dynamic. You can either rewrite the JavaScript in Python, like maybe it's just a really simple thing that you just do a form submission to the server, and you get back some data, and you can treat that like an API. But the other thing you can do is you can actually wrap the JavaScript they send you in Python SpiderMonkey, which is the JavaScript interpreter you can access from Python. Execute their JavaScript, and then take the results. So WordPress Hashcache. How many of you guys have heard of this tool? So it's one of the attempts to decrease comment spam on WordPress blogs. And what I want to show you is that the simplistic method that it uses is something that might be something like what you guys are running into and is totally easy to get through. Well, easy asterisk, but doable. So let me show you the site. At scrapepycon.ashish.org/hashcache, there is Ashish's Hashcache demo. So this is a simple old WordPress install that for some reason lists my IP address at the top. That's kind of troubling. And there's comments, and I'm saying things. Look, it's great. There seem to be some like automatically added comments here. But you can tell that the comment form is protected by WordPress Hashcache. It's proudly advertising itself here. And what that means is that in the source code, yeah, so here in the well, I'll just inspect element. Form. Check it out. There's this hidden input, WPHC_value, that's been filled in with this thing. It's a hidden input. If I disable JavaScript, this value would be empty. It gets filled in by some JavaScript at the top of the page. So much JavaScript. That looks possibly right. Yeah. Okay. So here is this WPHC function that has some strange data blob at the top. Perhaps that's stored in my session cookie. I don't know. It does some computation with some XORs. It does some more computation with string from car code. And then finally, it evals the result. That's terrible. OK, so that's what it does. And whenever the document loads, it finds a WPHC_value element and sets the value of that to the result of that function. So does this look familiar to people who've run into JavaScript anti-scraping stuff before? So this is the kind of thing where it probably wouldn't be that hard to rewrite this in Python. Well, maybe this eval part is more interesting than I thought. But other than that, however, the WPHC data that you get changes based on your session. I read the source in the PHP behind the scenes. And you're not always that lucky when you're scraping other people's things. So here's what we'll do. We'll use string search. We'll use DOM search to find this script tag. We'll use string search to find this function. And then we'll load this function into a JavaScript interpreter that you can call from Python. Call the function, stash its value in the hidden field, and submit some comment spam. So let me show you the code that makes that real. Walk. Home. Yes. Okay, so here I decided to use HTML5 lib for no particular reason. The key here is import SpiderMonkey. I think SpiderMonkey is on PyPy, so you can just pip install it. You do need to install some C code first. It'll step you through that. We have this function here that searches through all of these script tags and checks to see if they contain function WPHC. And if so, then we stash their contents away here when we return the script tag itself. So we take this script tag source and we wrap it in a function definition for JavaScript. Here's the fun part. We make a JavaScript anonymous function that just contains the function body of WPHC. We create a JavaScript runtime, a runtime context, and in here, we're doing cross-language calling. So this is a string of a JavaScript code, and this cx.execute will actually execute the JavaScript code. And that JavaScript code just defines the function, and now we can call it and return the value. So now we have this very simple post comment where naturally we set robots.text handling to false, we instantiate a browser, we just double check that the page claims to be protected by hash cache, and if not, we would break. Finally, we parse the page, grab the source of the JavaScript, execute the thing. As it happens, you have to undo some mechanized feature where hidden fields are set to read-only. So we make them read-write so that we can set that hidden field and submit. So if you're convinced, wait, but what do we submit anyway? Here we are. So I'm going to submit a comment whose content is Santa Clara rules, and then an MD5 sum of the current time, just so I never repeat the same content. Wouldn't want this comment to look like spam. Right. Wow. Pardon me. Prezzo. Okay, so on the web, right now, there's no mention of Santa Clara, right? Oh, no. Maybe I can get the sucker. Did I spell SpiderMonkey right? Oh, man, this worked on my demo machine, but it's a different machine. Okay, well, I'll install this in a second. Try not to hold your breath too long. I think it's... Well, so now comes the time where you have to actually believe me that you don't have to believe me that SpiderMonkey is available by pip install. I'm about to show you. Oh, I might need a compiler. Oh, man. Luckily, PyPI is really slow, so I can install the dependencies as I think of them. Oh. It's a race against time. Well, it's totally going to work, I assure you. Well, maybe I'll let that go in the background and I'll keep talking. I don't need to keep you guys waiting for too long. Let's talk about CAPTCHAs. So, CAPTCHA, does anybody here not know what a CAPTCHA is? Right. So, if you're lucky, websites, when they try to prove you're human, they'll ask you to see a really simple CAPTCHA. Mailinator used to have a really simple CAPTCHA. Let's see it. I don't know if any of you have seen this CAPTCHA before. It's really amazing. I know, now I'm using up all my bandwidth. Okay, so this CAPTCHA says, I love Mailinator. It's very low resolution. But what's great about this CAPTCHA isn't just it, but the fact that there's only so many of them. This one is my favorite. I don't know what the right answer is. So if you just have a human look at these and make a lookup table, you'll discover that there's only so many. Yeah, so I think if we went up to 20, we get a 404 already. Yeah. Yeah. So there are 10, 1 through 10. Pretty easy to just make a lookup table. You don't even need to download the URL every time. You can just look for the URL. But if they were just rotating the URLs, if they were having the same data at different URLs, then you could just hash the data of the image and look to store that in your dictionary. So I a few years ago was trying to pull data out of a US Patent and Trademark Office database called Public Pair. And the first thing it does when you are presented with it is you see this delicious reCAPTCHA, which is actually pretty tough, supposedly. I haven't been following the machine learning research, but I still hear that these are reasonably difficult to crack. And certainly there's not like there's 10. There's a whole number of them. So what I did was I actually had my Python code download this image, show it to me as a human. It's mostly non-interactive code, but then it pops up a window. Oh, there's an image. Type, enter. And then I stop looking at it and it crawls whatever I need. So that's, I think, the best way to deal with CAPTCHAs, which is just prompt when you have them, and then once you have the authentication, keep going automatically. The other really good thing to do is to just go to websites like deathbycaptcha.com. So services like this let you buy solutions to CAPTCHAs. This one is pretty inexpensive. It's about $1.39 for 1,000 solved CAPTCHAs. That's a lot less than my monthly EC2 bill. And apparently they get solved pretty quickly, 14 seconds. Like, there's an API that you call, on the other end of which is the human. And you pay 0.1 cents per CAPTCHA. So you could just go that route. 14 seconds. Like, there's some like good engineering going on in distributing those among like people who are actually online, and yeah. And 96.2% is pretty high accuracy. It's interesting that it's not 100%, but I guess it doesn't have to be, because you could just try a second time and you'd be fine. And actually, in general, CAPTCHAs are considered broken when you can break them at about 80% accuracy, I think. Yeah, I mean, you saw the like malinator number 3. That CAPTCHA you can't tell either. And yeah, so exactly, the some CAPTCHAs that you can't tell, that's a substantial portion of this tiny fraction, probably. There are some other CAPTCHA solving strategies which are just fantastically evil, which I think I have a few minutes, so I'll go into. So how many of you heard about when people affiliated with 4chan rigged the voting for Time's online poll for top 100 most influential people? Yeah. So it was a pretty awesome stunt. Time had a web poll on their site where they listed like a couple hundred or maybe just 100 people, and they wanted you to rank them as to which ones were the most influential. So the website 4chan was started by this fellow Moot. So they made sure that Moot was the first person. But actually they rigged all the rest of the top 14. Marble Cake also the game. And then they, whoever they needed to vote for to make these letters fill in the right places. Marble Cake is apparently an IRC channel they used to use. It's kind of dark. Giant, yeah. So this was a great scraping exercise and a great exercise in CAPTCHA defeating, because there was a CAPTCHA when you voted. In fact, they were using reCAPTCHA. What the 4chan people did was they took advantage of the structure of reCAPTCHA. So if we look at public pair again, reCAPTCHA is famous for one of these images being from a book, and one of them being a computer-generated really tough test. So this is probably the book. This is probably the tough test. I think they pulled a stunt where the ones that were from a book, they built up a big enough image recognition list. And for the second ones, they used a chosen string and just kept answering that. So the thing is that, sorry, this one from a, no, I have it backwards. Well, maybe I should take a few minutes to reflect after the talk is over and figure out exactly how we can read the article, but basically they flooded the database, convincing reCAPTCHA that these unknown words had known constant values that the reCAPTCHA people were putting in. So they were just declaring this first word was like ASDF, and then they were actually solving the right-hand side of the CAPTCHA. And I guess they did something where they ended up recycling these. Oh, right. So they convinced reCAPTCHA that and they had enough of these words set to their chosen plain text, and then reCAPTCHA would let them in if they got one of either side right. So by first teaching reCAPTCHA this is ASDF, not that they used ASDF, then they could defeat the entire CAPTCHA mechanism. But why bother when you can just get it for, less than a penny? So that's a pretty reasonable thing to do, I guess. In terms of JavaScript, so I was showing you how to defeat WordPress hash cache. So this site, let's dive in a little more. I think that's what it is. I can't actually quite tell. Great. So this is a website where the entire thing is rendered at runtime. There's no HTML here. It's just injected by JavaScript. So, well, okay, there's a bunch of HTML, but actually most of it's empty. And then the rest of it's JavaScript. So, and it gets document.writed into the page. So my tools for scraping in Python don't really know where stuff's going to get document.written from JavaScript. This page is empty, but it's all right here. So maybe we should just automate Firefox. The tool I've used for doing that is Selenium Remote Control. There's some other web testing tools like Windmill. Let me just tidy up a few of these tabs. Yeah, so I have some code that I can show you folks. Sorry. First, I'm going to show you how to use Selenium to do a search on Google. And the great thing about using Selenium to do automated searches on Google is that they can't tell you're a bot because you're not a bot. You're a real web browser. And you're definitely getting all of those CSS and images and JavaScripts, whatever they want. But maybe it's very complex, so let's take a look. So the way that this is actually bundled test code. They've implemented it as a unit test. So in the setup, they create a Selenium object connecting to localhost port 4444, and they request that Firefox be the web browser they get. Actually, you can request different browsers like Safari or Chrome, IE. And then they open this URL, they find this thing, and they type this there, they click this button, and now things get kind of messy. We loop for a while, we do a delay loop, waiting for the title of the web page to get set to indicate that the search was actually taken. And then at that point, you have access to the entire contents of the browser. So you can peek inside, navigate the DOM from Python. And at the end, we tear it down. So I think that I have the Selenium Java code which runs that here. Oh, wait, I never finished this demo. OK, now's a good time to see if I've finished installing SpiderMonkey. Which, if only I can find my terminal. Do I just have it now? Yes! OK, great. Great. So now let's get back to comment spamming myself. I expected that to not just do nothing. Oh. Data loss warning, who cares? I'm scraping. Okay, so if all is well, I'm going to reload this and see some spam. Yeah! Santa Clara rules! So, this is my favorite way to run JavaScript by using SpiderMonkey, but it's kind of a rigged demo just because this function is so easy to isolate, and it doesn't do any much modification to the DOM. But this is relatively common in anti-spam stuff. Clearly, I should just get a career in spamming. Yeah. So the we're recording, right? So, yeah. So there is this cool tool called Selenium Remote Control. No, the Selenium IDE. Sorry, which you can click around inside Firefox, and it'll record Selenium code that you can select what language, like Python, that simulates the same clicks on the page. So it'll write up code as you click, which is pretty neat. That's called Selenium IDE. I don't know if I have it listed in the resources at the end. So this site was such a pain. The PTO pair. Like, sorry to have my tabs not all right. Yeah, so this is the site that was all JavaScript. In the end, I just used the Selenium tool to click around. And the site is pretty simple if you ignore the fact that it's made of JavaScript. So once you're automating the web browser, it's pretty easy to click through the things you need. There's two other tools I want to show you before I talk about the last couple of things. One is there's this tool called JMeter by the Apache folks, which lets you record your HTTP transactions between you and the web. You set it up as your proxy server in your web browser, and it records the headers you send and the bodies that come back. And it can also do that over SSL. So that's a kind of neat trick. It does a man-in-the-middle attack between you and the site that you're trying to surf to via SSL. I mean, luckily, you control it and your browser, so it's not much of an attack. So you'll see a certificate warning in your browser, you'll agree to it, and then JMeter will decrypt the conversation, still record all that conversation, and then re-encrypt it to the server. And there's this other really slick tool called Selector Gadget that I really have to demo. So it's a bookmarklet and a bit of JavaScript to let you click around on a web page and find what a good CSS selector and XPath selector is for that very element you're clicking on. So it's implemented as a bookmarklet. I'm supposed to bookmark this link. I'll add it to the bookmarks menu. Selector gadget. All right. So if I click on this thing, it's showing me at the bottom here. Maybe I can zoom in a bit. Wow, that's not what I wanted. Yeah. At the bottom here, it's found that this top box created by etc., because my mouse is in there, can be accessed via this particular CSS selector. So you don't have to do any work, you just move the mouse around. Some of the elements it doesn't find a really good path for, so it warns you that there's a few matches. But this bookmarklet edge, global toolbar left, like, super convenient. Firefox does have something similar built in, actually. If you inspect element, well, Firebug does. If you inspect element in Firebug, and these two might not get along very well. Let's try a different page. Yeah. So if you inspect element in Firebug, you can right-click on this paragraph tag and do either copy CSS path or copy XPath. And you can paste those right into lxml.html. That is one intense CSS selector. It's probably not the most simple one to get the job done. You can tidy it up. There's another bookmarklet that lets you, it gives you an editable window for CSS selectors. So you'd paste in this long thing, and you just keep removing chunks. It'll visually highlight the element that matches that CSS selector. So you just keep removing chunks until you have something that still matches, and then you declare that's small enough, and you put that in your scraper. So I guess you were talking during the break in the middle here about how the website you were trying to scrape is, like, requires you to manually find which div is which. But I guess this kind of thing would probably make it easier for you to select the XPath for that element, or the CSS selector path. So that's all I have for parsing and searching through web pages and downloading them. But I want to talk a little bit about different ways to download pages in parallel and give you a recommendation for doing that. And also talk about how to make your web scraping code actually easy to test with unit tests, which is a lifesaver. So if you have a whole bunch of web pages you want to download in parallel, you have a few choices. But the first thing to figure out is why you would want to bother. Maybe you can just wait. The nice thing about parallelism is that things come to you faster, but it comes with complexity. So the code gets more complicated. You end up spending more RAM, CPU, and bandwidth on downloading the pages. And there's this vague, invisible unit of fear that's like, how likely is it that this website is going to find me? And so the more you download in parallel, the more you're likely to run into that. But so if you want to download multiple pages in parallel, it's important. I think that the best way to do it is to separate the parsing from the actual downloading of the page. So I'll show you some sample code that does that. And I'll also show you different code snippets that do the parallel downloading with a few different tools. How many here of you have used Celery when making web apps? Okay. So Celery, by default, is a tool to let you run code in the background. It's really designed for this case of you have a web app that has something slow that needs to happen in the background, like downloading data from Twitter, that might even fail. So you don't want the web browser user to block visiting the website on receiving that data, so you queue that into the background. The way the Celery works by default is it uses multiprocessing. So I'll show you some code to just use multiprocessing directly. Oh, whoa. So pardon the misleading file name. This file name is called serial.py, but it's actually different ways to download things in parallel. And I scraped out this list of podcasts that seemed interesting to demonstrate downloading in parallel. So let's talk about multiprocessing first. I guess I should make this a tiny bit smaller. Or maybe just shrink this over. Yeah. Yeah. So with multiprocessing, you end up with one Python interpreter per download you want to do. The slow part in scraping is usually the downloading. It's not the parsing. It's nothing else. It's waiting for the server to give you back the answer to your request. It takes, tens to thousands of milliseconds. Everything else can be done in tens of milliseconds. So what we do here is we make a pool of workers, and we make a list of work. So For each URL, we're going to call a feed parser on the URL, which pulls data out of Atom and RSS feeds. And if we find that the feed contains any items, then we print a note about the items we found. Actually, for each feed, we print only the top item. So we'll create this 4-item multiprocessing pool. And inside the pool, we will do this asynchronous map where we, for every URL, call this function. It'll only call it 4 times at a time, and it'll make this queue so that as one download finishes, that frees up a spot for the next download to start. Finally, we use i.get to make sure that each result has finished executing. So this is what Celery does behind the scenes. And if you find that your web app is doing background jobs too slowly, you might increase the number of workers. The danger is that multiprocessing makes one entire Python interpreter per request you're downloading. So, I mean, in the case where I was benchmarking this at work, that was between 15 and 20 megabytes per Python interpreter. When you do 10 at once, now you have a 300 megabyte footprint. So you're paying a 270 megabyte RAM cost to do 9 extras of these in parallel. It works just great, though, but you end up being RAM constrained. So that's one way, and I kind of want to tell you it all sucks. Don't go out and do it. All you need is to do the data downloading in parallel. You don't need to, and you can do multiple downloads at once inside Python without forking a new Python process for each one. So the obvious name in asynchronous networking is Twisted. So let me step you through some Twisted code that does this. Twisted really forces you to write high-quality code, I would say. So the way that the Twisted code works differently than the multiprocessing code in that this worker function, it doesn't take the URL to work on here. It takes the contents of that URL. So this code is fast. Then we make, what we'll do is we'll somehow ask Twisted to download 4 of these URLs at once, and whenever one of them finishes, we'll pass the data that downloaded into this worker function. So we do that by making this kind of pool, like the multiprocessing pool. We create a list of calls to the get page asynchronous downloader, and after every get page gets passed a URL, which comes from our list of URLs, and we tack on the function up here to call when the data is finished downloading to process the data. Finally, when all that work is done, we stop the reactor. And was that like super crystal clear? Oh yeah, and at the end, we start the reactor. That's Twisted for you. I can step through this in some more detail, and I actually like Twisted quite a bit, but it requires you to think sort of sideways a lot of the time. So there's yet another actually easy to use mechanism, which is gevent. How many of you have used gevent, first of all? Okay, great. So let me ignore the imports here for a second. It'll look just like the multiprocessing code. What we'll do is we'll make a worker pool of size 10. We'll write this function that takes the URL as an argument, downloads the data from it, and if it finds any values, it prints them. Then finally, we take this list of URLs and we add tasks to the workers. But the difference between gevent and multiprocessing is that with gevent, you do this crazy thing first called monkey patch all. So gevent adjusts the way the Python socket module works, which all of the page downloaders we've seen so far use, so that whenever it starts downloading something, it then returns control back to the rest of the program so that you can have cooperative multitasking. So whenever you start downloading something, control returns to anything else that wants to do any compute work, which lets you run these in parallel. And the number of these you run in parallel is 10 because that's the size of the pool. This is just like the multiprocessing-based code, except it doesn't cause any extra memory cost because you're doing all this inside the same Python interpreter. There's no threads. There's just this kind of cooperative multitasking where when you start downloading something, control returns to any other tasks that want control. So this is totally awesome. You should all do it. And you can do it with gevent directly, like I show here, or you can finally use the wrapper that the request module provides for gevent. So if you want to think about this even less, which is fine, you can write your code like this. So requests by default, you call requests.get on some URL, and then it goes and fetches that content immediately. And so no other Python code can get executed while you're requesting that. Request.async actually uses gevent behind the scenes so that you can create these sort of promises of downloaded data. And then whenever the data actually gets downloaded, it'll call a function with the resulting response. So here we've written the scraping code to take the string data rather than the URL as the argument. This is actually a special object called a response object, and it has this attribute r.content that's available when the thing is finished downloading. So this is what I would say pretty nice high-quality code because this function operates only on the data, not on the URL you're trying to download it from. You then enqueue all these guys. Whenever the response is ready, you call handle one response, and then you just use async.map to execute all the promises inside this list and run at most 5 at once, or 500. Because you're not paying any extra runtime cost in RAM, you can crank this up really high, and your concurrency will go really high. Your program will just be waiting on more work. It won't be chewing up lots of RAM. Yeah.
Have you performed any benchmark comparisons? I know you mentioned you tried to do this before, but do you have any comparisons performance-wise in the examples you showed?
So I eyeballed them. So the question was, do I have any benchmarks comparing the performance of these different asynchronous page downloading examples? In the past few days, I just eyeballed them and ran each of them, and they seemed to run in about the same amount of time, which is to say that they were still network limited, but they were network limited in the same, slightly faster way than they were when I was downloading one at a time. I have benchmarked the multiprocessing strategy in terms of RAM and found that it was about 20 to 25 megs per Python interpreter. And it varied depending on how complex the app was. But that's all as far as benchmarking. I can also offer that this code is in the example, so we can benchmark it later too. But I guess the basics are that this, I think that all of these, the twisted version, the direct gevent version, and the requests.async secretly gevent version have approximately exactly the same cost in terms of runtime. Like, they'll take the same amount of time to run, they'll take almost exactly the same amount of RAM. So it's only a matter of, because those all do cooperative multitasking inside the Python process. So it's only at that point a matter of style, which one seems nicer to you. And if you want to think about it as little as possible, you should probably use requests.async because it's pretty well documented and it's pretty specific to this purpose. The gevent stuff is pretty good too. The stuff that I did using gevent before, I would probably just do using requests.async now. Yeah, so I like to call Twisted alien technology because they seem to have invented stuff that the rest of the development community discovers some years later However, they described it using different terminology that no one understood at the time. Glyph gave a great talk last year at PyCon about all the crazy, intense-sounding, twisted talks that have gone on over the years. And nowadays, so originally, I used to really hate Celery. Well, I used to hate using Celery because it made the wrong trade-off, because it used up so much RAM. It created one Python process for each request I was waiting on. So it spun up, it wasted 25 megabytes with a wish to do nothing. And then once that request finished, the 25 megs Python process would go away. A new one would get forked with a new startup cost. Super slow and super expensive in terms of RAM. And on things like EC2, RAM is a big thing. Anyway, but now Celery has a G-event backend which you can configure, although I haven't used it myself. So that's the story on async. Are there any questions about async in particular that I can clarify here? Are you all going to go out and write super fast async request code now that you can just use that module's async feature? I see some nods, that's good. If I'd known about this years ago, I would be a lot younger. That's not how it works. I would have gotten more done. I think that's how it works. Yeah. So the other aspect of scraping that I wanted to really emphasize is unit testing. So how many of you have written unit tests for any bit of code? Wow, nice. So how many of you have written any sort of automated testing for your scraping code? Okay. Wow, yeah, good job, Chris. Oh yeah, of course you did. Chris and I have worked on a different project together that I've seen as tests, and they're pretty good. So if you want to write scraping code that's actually testable, you need to do the downloading and the analysis of the resulting data separately. Otherwise, your tests take for frickin' ever, and you never run them. Let me show you what I mean. So I wrote some so-called untestable code. Oh, yeah. I'm going to... It's an unusual kind of test. This test passes whenever there's eggplant available for lunch. So, that's, and then if it fails, it should be the opposite, right? It alerts me when there's something delicious to eat, so I guess it should be. The logic is reversed. So we can run this so-called untestable code, and it runs fine. It takes like 0.3 seconds. Do it again, 0.3 seconds. If there were a bunch of these, though, there's 0.3 seconds would add up. So I wrote a more testable version of this, which looks very similar, but it's very slightly different. There's one function to do the downloading, and another function to find out if eggplant is available on the docket. So the test here, this test, finally, because this function takes this data as an argument, we can just download the menu today to a file and run this test on the saved version. So that's what I did. This test now has 2 lines. Neither of them actually goes out and fetches the menu. One of them pulls the menu off disk, and the other one checks if there's eggplant available. So crucially, this is a high-quality test for making sure we extract the information that we think we're extracting from a web page with particular contents. It's not good for like a monitoring system for eggplant for me, but that's not what unit testing is for at all. It's for making sure your code does what you think it does. And if you have constant inputs and outputs and constant code, then you can believe that your code does what you think it does. So the old one took 0.3 seconds to run. This one takes no time at all. Imagine how fast the dots would print if there were more of these. Like, it'd be awesome. Having written a bunch of testing code recently, having written a bunch of scraping code in the past 2-3 years, the code that we fix are the ones where there's data saved as a reference point. And so when we find that the app scraping no longer applies to the current version of the data on the web, I go and surf to that web page and I save the contents of that page in my web browser, and I add a test case to my test suite where I load up that particular bit of data, then I run that locally. It's a bit more work to make sure my tests are failing, but when they fail, it's super fast to fix them, which is great. The only difficulty with this is that your tests will be slow if you ever call code that goes and downloads data from the web synchronously. So if you're using feed parser, for example, it has a couple of modes you can run it in where it downloads data from the web without asking you to make sure it has everything. So you'll notice because your tests start running slowly, basically. Yeah, so similarly, LXML has a LXML.html. Wait, I think LXML.html has a parse mode that takes a file object that is presumed to be from the internet. So there's a slow way to use that too. If you do things this way, your lives will be better, but you'll have to be a bit more conscious. The other nice thing is that if you write your code this way, it becomes way easier to make it parallel, because you can make the downloading part be parallel and then pass the data into really fast extraction code. Yeah, so I can talk a bit more about how to do automated testing for other frameworks, in particular Twisted. Any of you here use Twisted on a regular basis? Okay. So I'll at least dive into that. So Twisted has this getPage function, which I glossed over before, but it works the same way as request.async. You get a promise that says, whenever I finish downloading this URL, I will call the function you specify with the data from that URL. So to make testing Twisted-based code a lot faster, I have this fake getPage, and it stores a dictionary of URLs to data. So whenever somebody tries to request this, the plan is that instead of actually going out to the net and getting that, I will use the string that I've extracted at initialization time of this object. So I extract this getPage function into a top-level name in my test code, and in the test suite, what I do is I mock out the call to Twisted getPage, and I replace it with my fake getPage. There should probably be some actual code inside the test, but what you see is enough to make getPage from Twisted return instantly with saved data that you've left around on disk. It would be pretty cool, and I haven't built this yet, to have there be two modes of this, where one is an online mode, one is an offline mode. So then you can run your tests fast, and then when you think they work, you test them against the actual websites and make sure that nothing crazy has happened. But I hope you guys all write that and email me about it. So I guess the other thing to talk about in this is that I'm using mock objects. How many of you have used mock objects when writing tests? So mock objects take advantage of Python's dynamicness. So in this test, we set up the environment so that if any other code calls out to twisted.web.client.getPage, what it gets is not twisted.web.client.getPage, but instead my fake getPage. We just monkey patch using the mock.patch method the getPage name inside the Twisted Web Client module, so that if any code that runs inside the test accesses that name, it gets my version instead. So that means that you don't have to modify your code to have like online mode and offline mode. You just adjust the environment it runs in, so that whenever it thinks it's calling the live getPage, actually it's going to call your fake one. And that's what patching objects with probably not really a mock, but good enough is for. So you can apply the same strategy to the original untestable one. The original untestable version of this code is so-called untestable because it's really slow. It'll take 0.3 seconds to download this web page. And I do it in line, and then I check the data. So what I've instead done here is, if I wasn't willing to rewrite this code, then I could use a mock here also. I've made a little fake URL opener that no matter what URL you try to open, you get back the saved menu you've stored on disk. So then I patch out urllib2.url open so that when I call has eggplant inside the test, it thinks it's calling urllib2.url open, but actually it's calling my fake URL open here. So it'll run faster. And let me just demonstrate that that really is running faster. Well, I see. You know, an error is, I got that error so quick. Yeah, so now the so-called untestable version of the code actually runs in the same no time at all as the re-architected version. So long as you're willing to mock out the calls to slow network code. So how do you all feel about that? Does that feel pretty clear as a strategy? So the fact that you can mock out your inline slow network grabbing code means that you can take your current slow code and make it testable just by altering the environment it runs in. So I think that's all I have in terms of material. There were some questions in the middle that I wanted to answer, but I think I've forgotten them. So maybe in general, if you all have questions, you can ask me. Thanks for sticking with me. Yeah, so my email address is in the middle, ashish@ashish.org, and you're all quite welcome to email me. I'll be updating the code samples to be a bit tidier in the next day or so after I get to sleep. And also, I'll be adding a link to these slides. So if there's like particular scraping things that you want to hear about that I didn't talk about, I might be able to talk about them if you ask. Yeah.
An example that you talked about earlier with LXML talked about how you could actually have a parser that would parse dirty or malformed HTML or XML. But what if you're trying to actually detect whether it's dirty or not? For example, you expect a clean HTML or XML document, but it's dirty, and you want to actually detect what part or what elements the parse does not like, not necessarily the first part that it runs into.
Got it. So to repeat the question, the question is, how can you use these permissive parsers to find out which parts of the document are invalid? And I mean, if you just want to find out if the document is invalid, you can run it through a validator. That's the best thing to say. All of these parsers, especially HTML5lib, rearrange their notion of what the document is all the way through processing it if they run into any changes. And they don't seem to log what their decision points were. But I'm actually really curious why that would be useful.
The case that I have an XML document that is being generated specifically for me. It's not necessarily the case that I'm going out to the web and grabbing it. It's something that someone is creating an export in XML, handing that to me, and it's in an example where I'm looking at it. It's supposed to be UTF-based, but it turns out they use a couple of non-UTF-based characters amongst some of the codes they send. But that was
Got it.
a use case. Good example.
Yeah, in the case where someone's sending you data that's possibly invalid, I think the best thing to do is to run it through a regular validator. I use the command line tool called NX, I think it's called NXML. I think so, and it can very clearly print validation errors. But you brought up something interesting I didn't really touch on, which is character set encoding problems. So, just to summarize the current state of the world with character set encodings, just barely fewer than the majority of web servers indicate what the character set of a text document they're sending out is. And surely some of those are a lie. So if you're lucky, everything is UTF-8, and UTF-8 is really easy to detect. It's pretty. If you try to decode something as UTF-8, it'll generally fail if it wasn't. Otherwise, you can use either Cardet or Beautiful Soup's module called Unicode Dammit to infer the encoding. Dammit is spelled D-A-M-M-I-T in this case. Yeah, and those will do a best effort job of detecting the encoding, but they can in fact detect it wrong. Ned Batchelder is giving a great talk on Unicode in a few days that describes all sorts of great horrors you can run into. But the silver lining is that the requests module, if you use its requests.get, it'll do its best to convert whatever you got to Unicode if it can do so cleanly, correctly, without asking you. So if you use requests, you're much less likely to run into problems. Any other questions or topics you'd want me to touch on a bit more? Yeah. Oh, yeah. Yeah, so the question was, why is there a file in the repository that's for use with Tor, which is an anonymity network? So Tor also uses socks. So the same tools you can use for, with SSH-D, you can use with Tor. Tor is a really great best effort volunteer run like service to the internet to provide anonymity to people who really need it. So it's pretty mean to use the main public Tor network to just anonymize your scraping. If you're doing like one download per long amount of time, like 10 minutes, it's not a big deal, I guess, probably. You can run your own Tor network, though, if you wanted to use that to do the cycling for you. Well, yeah, I'm not sure if you're running your own Tor network, how anonymous you would end up. The traffic signatures might be really telling, but other than that, yeah. Yeah.
It's fairly new to this, so the gray area of when you're just playing around and learning, and when you're really doing a big project and grabbing too much data. Where does that start? You gave an example of Yahoo Finance. I imagine that's the perfect industry for people that want to write robots and scrape data versus by actually just service.
Yeah.
Do I just practice grabbing from a page like that when I get blocked immediately, or are there, like, where's the line between education and like you have to really start worrying about which IPs you're using?
So the question is kind of, how can you tell when you're moving from a small project up to something where people are likely to block you, basically, or like education up until something bigger, and you have to worry about covering your tracks. I mean, approximately never is anyone going to sue you for doing too many requests. So you should just have a dandy old time, be careless, and then if you start running into limitations of some kind, then deal with them. And that's served me really well over the years. Yeah, it served me really well. Yeah, so I once wrote a scraper to download, well, I pieced together a bunch of separate code to download music from this for-pay that I was subscribed to online music service called eMusic when they were switching from a all-you-can-download to a like 25 songs per month model. And I mean, so if I were to have done that, it's the kind of thing where, on one hand, it was extremely clearly against the terms of service. But all they ended up doing was canceling my account and refunding me the money for that month, so that I wouldn't have a complaint that they canceled my service. So, like, go wild. Well, I guess they did catch me, that's true. But anyway. We can talk more later about if I should or should not have done that. But I mean, IP address hopping wouldn't have helped because it was tied to my logged in account. The fact that I had a logged in account is related to why they were able to cancel my account. If it's just IP addresses, all they can do is block IP addresses, generally speaking. Unless, so on the other side, on the other end of that spectrum, recently a fellow named Aaron Swartz was indicted for downloading too many journal articles from an archive called JSTOR. That's in a case some of you might have heard of. And he wrote a Python-based scraper called Keep Grabbing. By the way, the indictment is a really it's like a 15 pages edge of your seat joyride through the alleged crazy world that Aaron put together by writing Keep Grabbing and keepgrabbing2.py and signing on to the MIT Wi-Fi network, registering his computer first as the name Gary Host with the email address ghost@mailnator.com. And then when he needed a new one, registering it as Grace Host and ghost2@mailnator.com. So in that he got caught for, but these are that who's indicted for. I don't know how that's progressed. It's been 9 months maybe. That's an extreme example, but he probably downloaded some hundreds of thousands to millions of documents from a service that clearly was only permitted for use inside a particular academic institution. He didn't do anything like share the resulting documents, but he's still in trouble for abusing the service. But now that I've scared you, really, approximately never does anyone get in trouble for anything like this. And scraping Yahoo Finance is great. And in fact, people in the finance industry spend a bunch of time writing scrapers for each other's websites. And the industry does not collapse under the legal weight of those lawsuits. Yeah. Pardon me. Yeah, I mean, in the case where you get in trouble, there's usually piles of warning signs first. So. Yeah, just to repeat that for the video, if you're this fellow once worked at Bing Analytics and humbly requests that people indicate that they're bots so that they don't show up in the analytics when people want to just exclude the bots. And yeah, the fact that Google blocks urllib2, that user agent, but they don't block whatever requests uses. I think, and I checked, and requests does use something called requests and then the version number as the user agent. So in general, people don't block user agents until they're a real problem. So you might as well not lie at first. Yeah. Any other questions or problems you've been having that you want to think through aloud? Okay, well, thanks. I'll sit up here for a bit longer, so feel free to come up and ask me some more.